Okay, this is a continuation on following up on modifying your tube amplifier so it has a separate filament transformer in it, so it can receive a filament supply separately from the high voltage, so you can keep your amplifier warmed up before you start listening to it. And now I have made this modification for this amp, added an extra filament transformer, and actually I've had this amp running without turning it off with the filament on for about 4 or 5 days now. So I'm at a phase now that I am testing it for stability. First, of course, I tested it on my bench with a variac and with voltmeters to make sure that the voltages are good and safe. And indeed, with 120 volts input, I get 6.2 volts AC for the filaments of the input tube, phase splitter, and power tubes. The rectifier is not fed by the filament transformer, it's being fed through the high voltage transformer. And there's one thing that I have not mentioned yet as the benefit for this trick. So it not only increases tube life, but it will also improve the sound of your amplifier noticeably, because it leaves extra room for the high voltage, extra magnetic capacity from your power transformer. So it has the effect as if you increased your power transformer, so now it can draw more current. When there's a bass note, it can draw more current for dynamics. It will be able to recharge faster because it can supply more, because there is no more constant filament drain on the main unit. So now what I want to show you is to see how safe it is. It has been in my case, and for that I'm going to show you a temperature measurement, because to do this modification I use the filament transformer, which is oversized. So these tubes here require 6.4 amperes of 2.4 amperes of 6.3 volts, and I have a 6 ampere transformer inside. And when you have higher amperage transformer than what's required, you will get higher than specified voltage in the output. So they receive much higher voltage, and I needed to use resistors to drop that extra voltage. So the resistors are here in the chassis underneath this part, and of course when you use resistor to drop voltage, you are also dumping heat. The resistors produce heat. So now let's get a temperature measurement device, and let's measure what is the added temperature, what's the temperature rise because of those resistors. Because if the rise is too much, then the unit is not safe at all to leave it alone, and you cannot use this trick to increase your tube life, because you cannot leave it unsupervised under no condition. So now let's turn it on. So you see our ambient temperature is 25.2 degrees Celsius, and when we check out the amp, you see it rises to 31 degrees at one point. 31 degrees. Can you read it? Yes, I can read it now. So it's 5 degrees Celsius above room temperature. That's a very minimal temperature rise. So that will show that your amp, this is barely warmer than the floor. So this is safe, and this warming is the result of leaving this amp on for like 4 or 5 days. So because you need to know that if you turn on your amplifier and you check the chassis how warm it gets when you use it, the warmth it gets after 1 hour is very different compared to leaving it on without turning off at all. So after 1 hour you feel that it's okay warm, but if you leave it on for a day it will be searing hot because the temperature just builds up, so the transformers will start heating up and it just soaks up and sinks all the heat and will be hotter and hotter. So now in our case we know that this does not represent a fire hazard because it doesn't get as hot to cause a fire through rise of temperature. So thank you for checking in, and just remember my disclaimer that working on amplifiers is dangerous. It's a risk to life and property, and my disclaimer is that never ever do that unqualified if you do such work. Always remember, just like driving tips, you can watch all the driving tips online, but you must not drive a vehicle unless you have a driver's license. Thank you for checking in. Bye bye.